Hey, it's Dave with Twilight Designs. Today, I'll show you how quickly a status check on a project can turn into much more than you bargained for.
What's up, guys? So what's the goal to get finished today?
I'm estimating the wattage that the lights we are about to install are going to use so that I can make a decision as to whether or not the existing wiring and transformers can handle this additional load.
There's 15 bulbs on this run here. They're 0.9 watts each. As we go to the second, third, and fourth run, it's going to be more than 15 bulbs. So I calculated that we've got about 70 watts. I'm hoping that we don't have much more than 30, 40 watts on the existing wire. So I'm going to come over here to the transformer. And Jorge, stand over by that light, and when I unplug each individual transformer, let me know when those lights are coming on and off so I can determine which transformer it's on. So there's 3 transformers here. They should all be on right now. They are all plugged into this power strip that I'm not a big fan of, but if we unplug one at a time. Is it still on, Jorge?
Still on?
Okay.
Still on?
Okay, well shit.
I'd like to provide a little bit of context as to the nature of the problem that we're dealing with here. The client already has an extensive lighting system with a lot of fixtures. The system was originally installed as a halogen system, and at some point during its life has been upgraded to an LED system. The transformers were left intact, as well as the wiring and the infrastructure underground. The halogen fixtures were removed and replaced with LED fixtures. This means that we've got a lot more transformer capacity and a lot more wire in the ground than what is actually needed to power the amount of wattage that the system is currently consuming. So when we come in to add a patio string light system, we also have to keep in mind that these transformers are already set up on a home smart system and are programmed to turn on and off the way the client would like this new patio string light system to operate as well. So rather than installing more transformers onto a system that already has plenty, our intention is to utilize the wire that's already in ground to power the string lighting system that we're about to install. Before we just utilize the closest wire, I want to make sure that the wire that we intend to use has the capacity to handle the wattage of the string light system that we're about to add to it. To do this, I'm going to identify a single fixture that's in the proximity of the string lighting that we want to add, and I want to determine how many watts are being utilized by that wire. To do this, I'm going to the area of transformers that I believe is going to control this fixture. And when I turn off all the transformers, it does in fact turn off the fixture that we have in question here. But as I dig a little deeper into it, what I realize is that I can turn off any single one of these transformers and this light remains on. It's only when I turn off all 3 transformers at the same time does this light go off. What we can derive from this situation is that we've got a single fixture in question that in some way, shape, or form has wiring from each of 3 transformers that interact with it. This could have happened inadvertently through repairs through the life of the system, or it could have happened if originally the system was installed perhaps with a loop method that used to be popular, where you would have wiring from one transformer that would connect to a fixture, and then you would run that wiring back to the same transformer. But because we've got 3 transformers adjacent to each other, it's conceivable that maybe the other side of the wire at some point got ran back into a different transformer. Now you would have one wiring loop connected into 2 separate transformers, and as long as the polarity and the voltage conductor aren't crossed, it would never trip the breaker. Because our scope of work did not allow for making repairs to the existing system, we decided to identify an alternative fixture that we were able to test the wiring and make sure that we could accurately determine how many watts were in fact on that wire, and to make sure that that wire was not commingling with other transformers in the same space. Once we identified a wire that we could safely add the needed wattage to, we utilized that wire to power our string lighting system. This situation is a perfect example of why I think it's important to hire somebody that specializes in landscape lighting. Somebody that has the knowledge of an electrician, that can understand electrical principles and how they pertain to a low voltage system. somebody that has the experience of a landscaper, that knows your local plant species, their growth cycles, and that understands the environment and the effect your geographical location is going to have on the materials that you're about to install. And somebody with the eye of a lighting designer that knows fixture placements, beam spreads, light intensities, color temperatures, and knows how to put these components together to create a unique lighting design. And if you can find somebody with a passion in all three of these areas, you're well on your way to creating a lighting system that you'll enjoy and appreciate for years to come. Thanks for watching.
That's good. Take that wire.